Find the point or points where the tangent line for x squared plus xy plus y squared equals 3 is A, horizontal, and B, vertical. A horizontal line has a slope of 0, and a vertical line has a slope of positive or negative infinity. We're looking at the slope of the tangent line here, which is the derivative. So the first thing to do is find the derivative of the equation. We have an implicit equation here, x squared plus xy plus y squared equals to 3. It's not solved for y in terms of x, and therefore to find the derivative we will have to find it implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. On the left side, the first term, the derivative will be power rule, bring down the power, subtract 1 from it. The second term is a product rule. The derivative of the first x will be a 1 times the second left alone y, plus the first left alone x times the derivative of the second. The derivative of y is 1, but then times y prime due to the chain rule. Every time we take the derivative of a y term, we get a y prime due to the chain rule. The third term, y squared, will be power rule, bring down the power, subtract 1 from it, and then the derivative of the inside will give us a y prime. On the right side, the derivative of a constant is a 0. So we have 2x plus y plus xy prime plus 2y prime equals to 0. We want to solve for y prime here, so this will be done by isolating the y prime terms. We have two of them. We have this one, we have this one. The other two terms need to be taken to the other side, so we'll subtract them over. X y prime plus 2y prime equals to negative 2x minus y. Now we can factor y prime out on the left. And we can solve for y prime by dividing both sides by what's inside the parentheses on the left side. So we have for our derivative negative 2x minus y over x plus 2y. For part A, we want to find where the tangent line is horizontal. A horizontal tangent line has a slope or a derivative that is equal to 0. Now down here we have our derivative, which is our slope. For this to equal to 0, we need the numerator to equal to 0. So we're going to set the numerator, minus 2x minus y, equal to 0. That gives us that minus y equals to a positive 2x if we add it to the other side, or y equals to negative 2x. And there's the relation between y and x that needs to hold true to have a horizontal tangent line. We want the points, therefore we're going to take the relation we just found and put it into the equation that we need to be on for the tangent line. So our equation is x squared plus xy plus y squared equals to 3. We're going to replace each of the y's with a negative 2x. So we'll have x squared plus x times negative 2x plus a negative 2x squared equals to the 3, which will give us x squared. X times a negative 2x will be a negative 2x squared. And then a negative 2 squared is a 4, and an x squared equals that 3. We can combine all the terms on the left together. 1 minus 2 is negative 1 plus 4 is 3, since all of them are x squared terms. Equals to 3. Let's divide both sides by 3, so we have x squared equals to 1, and now we can take the square root of both sides. Do not forget the plus or minus. So we have a positive 1, and we have a negative 1. We're under the condition that y is negative 2x, so we need to find the corresponding y coordinate with each of these x coordinates. So if x is equal to a positive 1, y is negative 2 times whatever the x is, negative 2 times 1, which gives us negative 2, so we have an x coordinate of 1 and a y coordinate of negative 2. We also have the x coordinate of negative 1, and the y coordinate will be negative 2 times whatever the x coordinate is, which is a negative 1. Negative 2 times negative 1 is a positive 2. We have an x coordinate of negative 1 and a y coordinate of positive 2. There's the 2 points where the tangent line would be horizontal. Now let's find where the tangent line is vertical. A vertical line has a slope for the tangent line or the derivative that will be a positive or negative infinity. This is found by taking the derivative and having the denominator be equal to 0 down here. So we're going to take that denominator, x plus 2y, instead of equal to 0, which leads to the relation that x equals negative 2y. Once again, we can take that relation that we just came up with and put it into our original equation to find the points. So we have our original equations, x squared plus xy plus y squared equals to 3, plugging a negative 2y in for each of the x's. Negative 2y squared plus negative 2y times y plus y squared equals to 3. Negative 2 squared is a 4, y squared. A negative 2y times a y is a negative 2y squared. And then plus y squared equals to 3. When combining all the terms together on the left, we have a 4 minus a 2, which is a 2, plus 1, which is a 3. Y squared equals a 3. We can divide both sides by 3. Y squared equals to 1. And therefore, take the square root of both sides. Don't forget the plus or minus. Y can be a positive 1 or a negative 1. We need to find the corresponding x coordinates to each of these. We're under the condition that x is negative 2y. So we're going to take each of the y's one at a time and find the corresponding x. So x, if y is a 1, will be negative 2 times 1, which is a negative 2. So we have an x coordinate of negative 2 and a y coordinate of positive 1. We also have the y coordinate of a negative 1, so the x coordinate will be negative 2 times negative 1, which comes out to positive 2. So we have an x coordinate of positive 2 and a y coordinate of negative 1. And there's the 2 points where the tangent line will be vertical.